Hello, everyone. Today we will learn section 2.7 cylindrical and spherical coordinates. Okay, there is a learning objective. We have a cylindrical coordinated system in 3 dimensions. So this is come from polar coordinate system, which is r theta. Then we add one more coordinate, which is z. So let me read this one. Cylindrical coordinate system in 3 dimensions. R theta or polar coordinate of the points projection in the xy plane, z equal to z, Cartesian coordinate system. So we have a xyz in triple, not pair, oral triple, oral pair or oral triple. Then we can express cylindrical coordinate system r theta from the polar coordinate, and then z, we are just use z as well from the Cartesian system, Cartesian coordinate system. All right. Okay. So look, we have this is a Cartesian, not product, Cartesian coordinate system, right? Let me write down. Cartesian coordinate. Let me denote this way, and then this is a cylindrical coordinate. So they say that the r theta or polar coordinate of the point projection in the xy plane, xy plane projection, right? And then using just z as the same z as Cartesian. Okay, so here is a note. This is angle theta, right? And this is x-axis. And then we have length, which is r in the case, or. So the length of the hypotenuse is r, and the angle theta is a measure of the angle formed by the positive x-axis. Means that this is from the positive x-axis, right? And then this is a negative. So positive x-axis, and then here is negative x-axis. So their form of the length of hypotenuse r and angle theta measured from the positive x-axis. All right. Oh, from here. Okay. We have a theorem 2.15 conversion between cylindrical and Cartesian coordinate system. So we knew x equal to r cosine theta from the trigonometry, right? Y equal to r sine theta, right? But then we add one more coordinate, which is z. So here, z equal to z. And then we have r squared. So this is, basically this is from Cartesian to, actually cylindrical from to Cartesian, right? And this is from Cartesian to cylindrical, right? Cylindrical. Okay, so let's do example. Okay, so here is the example. So plot the point 4, 2 pi over 3 and negative 2. That is, this is r theta z, right? In cylindrical coordinate system. So we need to plot the point. So let's do it. So this is z. And this is x. And this is y. Okay, we have to, can I see? All right. So we have to measure from the positive x-axis and then also length of R2, right? So theta, theta equal to 2 pi over 3. So let's take a look at this one. So from here to here, 90 degree, which is pi over 2, right? And then if we have negative x-axis, there will be pi, right? So this is a think pi. And then this will be 2 pi, right? 2 pi from here to here, right? Okay, and then we want to express 2 pi over 3, then before pi, right? So actually pi over 2. After that, I'm sorry, did I say 2 pi? Ooh, so bad. Ooh, good thing I catch that up. Pi over 2. I meant pi over 2, right? Okay, so I want to express 2 pi over 3. So not the, looks like a 45. I want to make a before, right? So yeah. So let's measure the radius equal to 4, approximately 1, 2, 3, 4, right? Okay, then negative 2, theta equal to 2 pi over 3. And then z equal to negative 2, so we make a parallel with the z x-axis and then measure just a 2 unit down, right? So parallel with the z axis. 1, 2. Ooh. So there will be 4, 2 pi over 3 and negative 2. Oh, you cannot see. All right. Yeah. Okay. Now let's find out rectangular coordinate system. Rectangular means it's same as the Cartesian, right? Cartesian coordinate system, same. Okay, so we are using this formula, right? Copy that. Okay, so we have point this. All right, x equal to r. So x equal to 4 cosine 2 pi over 3. Can you please think about what is cosine 2 pi over 3? 4, negative 1/2. Very good. Equal to, we get negative 2. Y equal to r cosine theta. So 4 sine 2 pi over 3. Can you please think about what is a sine 2 pi over 3? Very good. So square root of 3 over 2. Excellent. So we will get 2 square root over 3, which is, thank you, 3.46. Z equal to negative 2, same as, right? Okay. So we have Cartesian, which is a rectangular coordinate system, which is x, y, z, which is negative 2, 2 square root over 3, and negative 2, right? Let's find out. Yeah. So negative 2. So we have not straight down. Looks should be straight this way. Okay, so negative 2, so 1, 2, negative 2, then 2 square root 2, 3, which is approximately 3.46. So we make a parallel with y-axis. So 3.46, 1, 2, 3.46. It's about here, right? And then, little bit off. Let me see. Two, and then 1, 2, 3.46. And then z equal to negative 2. So 1, 2. Yeah. So approximately similar. Yeah. Same point. So there will be equal to negative 2, 2 square root 2 over 3, and negative 2. Okay. Oh, you guys okay? All right. Let me bring theorem 2.16. Converting among spherical and cylindrical and rectangular coordinate system. Before we do that, let's do a lot of examples. So I need to cover a lot of things before that. Okay, let's convert. We have a Cartesian or rectangular coordinate system point into cylindrical coordinate. Okay. All right, so then we are using this formula. Copy, paste. So let me highlight, yeah. Okay, so r squared, x squared plus y squared, so 1 squared plus negative 3 squared. We have to have a like r theta z. So can we do that just r directly, right? So instead of r squared, right? So we can make it directly. Okay, then what do you get? We get square root of 10. Very good. Now, what is tan theta? y over x, so -3 over 1, right? Okay, angle theta, which is inverse of -3, right? So if we calculate this one, it's -1.249 radians. Okay, so let's take a look. We have note x equal to 1, y equal to -3. That means the angle theta is in, this means is in quadrant 4, right? So we have radians -1.249, which is clockwise, so quadrant 4, but we want to express it as a positive angle. So look, this will be angle theta. It's -2.249 radians. Okay, if we add 2 pi, right? So plus 2 pi, then we get angle from here to here. Yeah, counterclockwise. Yes. So that will be 5.03 radians. Make sense? So plus 2 pi equal to 5.03 radians. Okay, now the last one is z equal to z, right? So we have z equal to 5. So let's arrange the cylindrical coordinate, which is r theta z, which is r, which is square root of 10, and theta, which is 5.03 radians, and z equal to 5. Oh, you cannot see. So sorry every time. You cannot see. I'm very sorry about that. All right. Now, let's identify surface in the cylindrical coordinate system. All right. Let me bring all the pictures here. Okay. So let's take a look this picture. So we did a YZ plane, XZ plane, XY plane last sections, previous section, right? So YZ plane, X equal to 0 or X equal to some number, right? So moving this way, YZ plane, XZ plane, Y equal to 0. So moving this away, right? So Y equal to some number. XY plane, Z equal to 0 or Z equal to some number, right? Moving up and down. Yes. Okay. And then we can see that there's a cylinder. Yeah. So we can use this one as cylindrical coordinate, which is r equal to any number. In the case we measure the radius is 3. So I put the 3 there. We have plane. Looks like XZ plane. Yeah, moving this way, right? But then they say that this is a half plane. And if we want to express this one, instead of y equal to 0, right? We express as angle theta, some number, radians. Some number means radians. In that case, it's theta equal to 0 because the theta we measure from the positive x-axis from here, right? So stay there. So it's 0 radians. Okay, we know this is xy plane, right? So I'm measuring z equal to 2 there. Okay, let's take a look. Describe the surface with the given cylindrical equation. So angle theta pi over 4, then think about this one. Half a plane, right? But then this plane is supposed to be here. So we measure angle, which is pi over 4. Yeah? So this is a 45 degree, which is pi over 4. Make sense? Let me screenshot the picture from the textbook, this one. Okay, how about second one? R squared plus Z squared equal to 9. So think about this. R squared, we had formula when we convert from R squared. Yeah. From the Cartesian to the cylindrical coordinate, right? So we have this, right? Let me write down note. R squared equal to x squared plus y squared. Now we can express this one as x squared plus y squared plus z squared equal to 9. Now what can you see? Bingo. Very good. This is a sphere, right? Sphere. R equal to 3, right? Good job. Okay. This one is a little bit hard. Z equal to R. So R also we can express as R equal to square root of x squared plus y squared, right? So when R changes, Z changes. Makes sense, right? So when R equal to 1, Z equal to 1, R equal to 2, Z equal to 2. So R stands for radius, right? So it's a cone. So I draw in the decimals. Let's take a look. So Z squared equal to square root of x squared plus y squared, which is r, not the r squared, right? Just the r, right? So this is the one. So let's screenshot, and then I'm gonna attach there. Okay, so let's do an example. Let's say using find the cylindrical equation of y squared equal to 10 minus z squared. Yeah. So we want to express r or cosine theta, sine theta, and then z, right? Cylindrical equation. Okay, so let's do it. We don't want to y squared, right? So y squared, let's see. So we had r squared equal to x squared plus y squared. Then y squared, then r squared minus x squared, right? So let's substitute there. Y squared as r squared minus x squared. 10 minus z squared. Okay, now we have x squared. So x equal to r cosine theta. So there will be r squared minus, and then x squared will be r cosine theta squared, right? equal to 10 minus z squared. Okay, let's simplify. So r squared minus r squared cosine squared theta equal to 10 minus z squared. Then we can factor out with r squared. 1 minus cosine squared theta equal to 10 minus z squared, right? Then we know that note. Cosine squared theta plus sine squared theta equal to 1. Then, ooh, um, 1 minus cosine squared theta, then sine squared theta equal to 1 minus cosine squared theta. Okay, so there will be, this will be sine squared theta. So r squared equal to 10 minus z squared. Z is okay because in the cylindrical cell, the cylindrical cell, in the cylindrical equation, Z is Z, right? Yeah, so it's okay to have that. All right, how about this? Find y equal to x squared. Cylindrical equation. Okay, note y. Y equal to r sine theta, right? And x equal to r cosine theta, right? Okay, so there will be r sine theta equal to r cosine theta squared, right? So let's make a squared this way because we had the experience earlier, square. Okay, let's simplify. So cylindrical, we want to express, this is equation, right? So equation r equal to something better. Yeah. So we have so for r. Okay, now we divide by r both sides. So we get sine theta equal to r cosine squared theta, right? Okay, r is here. Then we divide by cosine squared theta both sides. Then we have sine theta over cosine squared theta equal to r, right? Okay, let's simplify. Actually, we can just leave it like that, but we can simplify more. So sine theta over cosine theta equal to 1 over, I'm sorry, 1 over cosine theta equal to r, right? Sine over cosine, what you get is tangent theta, right? 1 over cosine, which is secant theta. That is the answer. Is it okay? Okay. Now, finally, we have a spherical coordinate system here. So let's talk about that. We are using Greek letter rho. In that case, rho. We read rho. And what is a rho? is the distance between P, the point P, from the origin. Yeah, this is origin, 0, 0, 0, right? Origin. So 0, 0, 0. So that's the rule. Distance from origin to the P, the point P, right? That's the rule. Okay, we have a angle theta. It's the same measurement from the cylindrical coordinate. Means that we measure that angle theta from the positive x-axis, right? So this is the positive x-axis and measure same way, okay? Measured by positive x-axis, yeah. And then there is a phi. So we read in Greek, it's a phi, but in English, they read phi. So let me read in Greek, phi. In English, phi. I just write as a pronunciation, phi, okay? Sometimes I will read phi because I learned that way when I was a student. And then if I using phi, people may get confused with the pi, right? We have a pi, yeah. All right, so this is also angle. We measure from positive z axis. So that is phi, yeah. And then they say that the phi is between 0 to pi. See? How can I do that? Phi is between 0 and pi, right? So let's just using phi. I get confused. Let's do phi, all right? So I'm gonna read this is a phi, phi, phi. Okay, so this is Cartesian, we know that, right? Cartesian coordinate or rectangular coordinate, right? And this is rho theta phi is a spherical coordinate. And this is r theta z is cylindrical, right? Coordinate. Okay, so let me bring how to convert spherical to cylindrical, cylindrical to rectangular, rectangular to spherical, and yeah, we did a cylindrical earlier, right? So here is converting among spherical, cylindrical, and rectangular coordinate. Before we do that, let's talk about that. We have x equal to r cosine theta, y equal to r sine theta, z equal to z, and r squared equal to x squared plus y squared, and then tan theta equal to y over x, z equal to z, right? So this formula, we convert this one from the cylindrical to rectangular, and this one rectangular to cylindrical, right? Yeah, z equal to z. Okay, now this is converting from spherical to rectangular. X equal to rho sine phi cosine theta. Y equal to rho sine phi sine theta. Z equal to rho sine phi, right? And this is converting from rectangular to spherical. Rho squared equal to x squared plus y squared plus z squared. Tan theta is the same, y over x. Phi equal to r cosine z over square root of x squared plus y squared plus z squared. And then convert from spherical to cylindrical. R theta z, right? So R equal to rho sine phi, theta equal to theta, z equal to rho cosine phi. And this is a convert from cylindrical to spherical. So rho equal to square root of R squared plus z squared. Theta equal to theta, phi equal to R cosine z over R squared plus z squared. Yeah? Okay. So everything is here. Okay, so here is example. Plot the point with a spherical coordinate a pi over 3, pi over 6, and express its location in both rectangular and cylindrical coordinate. Okay, let's plot. Z, you cannot see X. Okay, rho is distance from the origin to the point. So we don't know the point. That's the, we have to do that, right? Let's approximately make 8 then. So we don't know here or here and here, right? So maybe we can do 8 later. Then rho. Rho is the distance from the origin to the point. That's the rho, right? Okay. Pi over 3, so we measure angle theta from the positive x-axis. Distance. Distance from origin to the point. Okay, and then theta, measure angle from the positive x-axis, and phi, measure, let me just copy because same thing, measure angle from the positive z-axis, yeah? Copy. Z. Z. Okay, so let's measure angle pi over 3 from the positive x-axis. So looks like this is a 45, right? In the middle. So a little bit more than is pi over 3. So, looks like this is the middle. So this is pi over 3. Okay, now phi pi over 6. then phi pi over 6. So we knew phi is between 0 to pi, right? So must be between here, right? Then pi over 6 about there. Mm, 6 over 6 is a little bit big. How about that then? Over 6. Yeah. Okay, so did I say that phi is from the 0 to pi, right? So let me make this is 0 because we measure from the positive z-axis, right? Then that will be other side of z will be pi then, right? So I think I said it here, right? So that's not right. So this is 0 to pi, right? Okay, then I want to measure if we have this is pi, then this will be uh, in the middle, pi over 2, right? So I want to make a little bit 1/3, 1/3. Is it 1/3, 1/3, 1/3? Yeah. So pi over 6. And this pi over 3 and then pi over 2, right? Okay. Now, I just want to measure the 8 units because it's a row. We measure distance from 0 to origin to the point, right? So 1, 2, 3, 4, 5, 6, 7, 8. How about that? Yeah. And then this one. Is it right triangle here? Oh, no. Hmm. Yeah, the measuring is not accurate, right? That's why I want to make a I was gonna use it earlier, so a little bit better approximation, a little bit better than earlier. Yeah, is it? Say just okay. Whew. All right. Now we need to find for the coordinate. Okay, for rectangular, this is a spherical, right? Okay, so spherical to rectangular first. So let's using this one. Number 1, copy. Okay, so we have this. So x equal to rho a sine phi pi over 6 cosine theta. Okay, so that will be 8 sine pi over 6, which is 1/2. And cosine pi over 3, 1/2. Simplify, we get 2. Y equal to rho sine phi sine theta. So a sine pi over 6 sine pi over 3, right? A sine pi over 6, 1/2 sine pi over 3, which is the square root of 3 over 2. Simplify, then we get 2 square root over 3, right? Okay. Z equal to rho cosine phi, rho, which is 8 cosine pi over 6. Cosine pi over 6, so we have a square root of 3 over 2. A square root of 3 over 2. Then we get 4 square root over 3, yeah? So we have x, y, z, which is 2 square root over 3, 4 square root over 3, yeah? That's a rectangular coordinate. Okay, cylindrical coordinate. So we have a spherical and then cylindrical, right? So we are using this one. Copy. All right. I need this point. Copy. Just a little bit smaller. Oh, too late. Okay, so let's do it. R equal to rho, which is a sine phi pi over 6. We had experience sine pi over 6, so 8 1/2, which is 4. Theta equal to theta, so theta equal to pi over 3. Z equal to rho 8 cosine phi, which is pi over 6. That is 8 square root of 3 over 2, which is 4 square root over 3, right? Okay, r theta z equal to 4 square pi over 3 and 4 square root 2 over 3. Yeah, that's it. Yeah, spherical to rectangular, and then spherical to cylindrical. Yeah. Okay. You can make approximate those number. We can plot the point. Those point will be same as here, right? So there will be 8 pi over 3 pi over 6, and there will be let me see, 2 square root over 3, 4 square root over 3, right? 4 square root of 3, And then make approximate. So 4 pi over 3, 4, and then square root over 3. 4 pi over 3, and 4 square root. Oh, can you see? Oh, you see that, right? Okay. Let's do one more. The other way. Okay, so we have an example convert rectangular coordinate to spherical and cylindrical, right? Okay, so let's do spherical first. So rectangular to spherical. So let's using this one. Copy. Okay, so rho squared. Oh, we need a rho, right? So let's make a rho equal to square root of x squared plus y squared plus z squared. Okay, so I need this. Copy. So we have square root -1 square plus 1 square plus square root of square root of 6 equal to, then can you please calculate? 8. Good job. I mean uh it's not the, yeah, square root. Yeah. Then we can use that this is 2 square root of 2, right? Right? Yeah. Okay. Now tan theta, which is y over x, so 1 over -1. Ooh, cannot see. Okay. So like earlier, this is a positive, positive. Y is positive. Y is positive. X is negative, right? Then what quadrant? X is negative, positive. Quadrant 3, right? Hold on 1 second. Quadrant 2. So quadrant 2. The theta will be quadrant 2. So theta will be almost done. Okay. So we can find easily inverse of tangent, right? Of -1. Oh, sorry about that. -1. So what do you get? 3 pi over 4. Excellent. Okay. Now, the phi, I need this one. Copy, paste. So we have a r cosine of z square root of 6 over, we have a square root of 8. Okay, can you please calculate? Oh, this is a nice number. So we simplify. So we will get arc cosine square root square root of 6/8. There will be arc cosine simplify. So we have 3/2. Yeah. Square root of square root of 3/2. Yeah. Okay. Okay, then r cosine inverse of cosine of square root of 3/2, we get pi/6. Phi equal to pi/6. All right. So we have rho theta phi, which is 2 square root of 2 theta, which is pi/6. No, theta equal to 3 pi/4. And phi is pi/6. Yeah. Oh, you cannot see. Sorry. Always. Okay. Now cylindrical coordinate. We can use the cylindrical coordinate easily, right? So what was it? R equal to square root of x squared plus y squared. And tan theta equal to y/x. Z equal to z, right? That's we can find easily. But let's do the another method because we had the experience how to find this one, right? But then let's try spherical to cylindrical, right? So new experience, right? New method, we're using it. Spherical to cylindrical. Oh, yeah. So let's use the spherical to cylindrical. Copy. We have there, right? So R equal to rho. So rho will be 2 square root of 2 sine phi. Sine phi, be careful. Sine phi, phi is pi/6. So that will be 2 square root of 2 sine pi/6, which is 1/2. So we get square root of 2. Theta equal to theta, so 3 pi/4. And z equal to rho cosine phi. So rho equal to 2 square root of 2 cosine phi, which is pi/6. Yeah. Then 2 square root of 2 cosine pi/6, square root of 3/2. Simplify. We have a square root of 6. So we have r theta z, which is square root of 2, 3 pi/4, square root of 6. Yeah. Okay. Now, let me bring the picture again here. Okay, so let's take a look at the first one. First one has the shape is a sphere, right? We had the equation, sphere, x squared plus y squared plus z squared equal to some number, which is r squared, right? Or if we have a different center, except beside the origin, we have to have denominator, right? So we had that before. But then what if we want to express as a spherical equation, right? Then we are using rho equal to some number. In that case, it's rho equal to 3. Yeah. So basically, we had a cylindrical equation earlier. So basically like this, same shape of the figure, we can express as rectangular equation, right? Just regular equation. And we can express as that same shape as a cylindrical equation. And if we have the same shape, then we can express as spherical equation. Okay. All right. So let's take a look at this one. So in that case, it's radius, right? So rho equal to 3 means this is radius. But then we had earlier, rho means we measure distance from 0 to the origin to the point, right? So from here to here is a 3 then, which is rho. Yeah. Okay, second one, we say the half plane. And then the form of equation is theta equal to some number. In that case, there is no angle theta, just stay there. So theta equal to 0, radians. Okay, now third one, we say that this is a half cone. And then we express this figure phi equal to some number, radius. Yeah. So what was the phi? We measure angle from the positive z-axis, right? So in that case, it's phi equal to pi over 4 because we measure from the positive z-axis here. So phi equal to pi over 4. Yeah. Okay, let's do example. Okay, so describe the surface with a given spherical equation. So theta equal to pi over 3. So theta equal to pi over 3, theta we measure from the positive x-axis. So we have a half plane like earlier, right? So this half plane move a little bit to measure pi over 3, right? Yeah. So half plane. I try to draw better. Hmm. Yeah. Okay. Second one, we have phi equal to pi over 6. So phi we measure from angle. Let me write down. Note. Measure angle from the positive x-axis. This is measure angle from the positive z-axis, right? What was that? This one earlier is a half cone, right? So there will be, what's the 5 pi over 6. Yeah. So this is half cone. Let me try. So half cone. Not there. So this is 5 pi over 6. Yeah. Okay. I'm gonna show you how to find just a rectangular equation here. Okay, phi equal to 5 pi over 6. So formula we have phi equal to, yeah. So let me using this one. Copy. So we had the formula. Phi equal to that. Then phi equal to phi equal to 5 pi over 6, right? So we have 5 pi over 6 equal to arc cosine of z over square root of x squared plus y squared plus z squared, right? Okay, so we can express this way, right? So swap with a cosine, inverse of cosine, right? So we will have cosine 5 pi over 6 equal to z over square root of x squared plus y squared plus z squared. Okay, so what do we get the cosine 5 pi over 6? We know that 5 pi, pi over 6, which is square root of 3 over 2, right? So it's a second quadrant, so it's negative, equal to z over square root of x squared plus y squared plus z squared. Okay, so we have a square root in the denominator, so let's make a square them. So we get 3 over 4 equal to z squared over x squared plus y squared plus z squared. So let's multiply this way, right? So we get 3 of x squared plus y squared plus z squared equal to 4z squared. Okay, now let's make a 0 one side. So we divide by 4 both sides. So we will get 3 over 4 x squared plus y squared plus z squared equal to z squared. So make one side 0. So negative z squared, negative z squared. Okay, so let's distribute everything. Then negative z squared. So we have 3 over 4x squared plus 3 over 4y squared plus 3 over 4z squared minus z squared equal to 0. So let's combine. Yeah, So 3/4 minus 4/4. We get the negative, right? So we have 3/4 x squared plus 3/4 y squared minus 1/4 z squared equal to 0. Okay, then this is not right. The picture is not right. Okay, so this one from the last section, quadratic surface, we get this is elliptic cone. And then this one opens z axis because we have a negative on z, okay? But then we have to measure phi from the positive z-axis, right? So once again, if we measure phi from the positive z-axis, then that will be pi, right? And then if in that case, then that will be pi/2. Then 5 pi/6 will be how much? Pi/2. So we passed the pi/2, right? Okay, so I got this screenshot from your textbook. So it's like this. We have a cone, where's my iPad? Uh, we have a half cone earlier, right? So like this, and then I say that phi equal to 5 pi/4, then uh, going to here, that will be 5 pi/2, right? And then from here to here is pi, right? So if that cone is flat, then that's a 5 pi/2, right? So like this. This one is flat here, yeah? Okay, now that flat, from this cone flat, and then move this way, yeah? The bottom shape of the cone. Make sense? So I want to measure 5 pi/6 like that, right? Because we measure phi from the positive z-axis, but then textbook measure like that. So looks like they measure from the negative z-axis, yeah? So this is the one, right? So what do you think? Yeah. Okay. So only the half cone, right? So I wanted to make it clear about that. All right, so let's do two more, then we're done for this section. We have, see, rho equal to 6. Rho we can use as a sphere, right? As R. Then the radius equal to 6. And this is a sphere we did earlier. Yeah? You wanna check? Yeah, let's check. So let's make a square then. Rho squared equal to 6 squared. Yeah? So rho squared, what do you get? X squared plus, no, that is correct, right? Y squared. I want to think of square root, yeah. G squared equal to 36, yeah? Ta-da-da. This is a sphere, right? R equal to 6, yeah? And then the center at the origin, 0, 0, 0. Yeah. Okay, the last one. Last one. We have rho equal to sine theta sine phi. Okay, so we want to make like an equation so that we can figure out what kind of spherical equation is this. Yeah, so let's make a times rho together. So we make rho squared other side. So times rho times rho. So there will be rho equal to sine theta sine phi. Then rho square equal to rho sine theta sine phi. So this one comes from the one of formula. So that is rho square equal to y. This is from cylindrical, not cylindrical, spherical to the rectangular coordinate, right? So let me write down note. Y equal to rho sine theta sine phi. Rho square equal to x square plus y square plus z square. We did earlier, right? So x square plus y square plus z square equal to y. Okay, let's make one side is 0. Then there will be minus y both sides. So we have x squared plus y squared plus z squared minus y equal to 0. Let's make a completing square. Yeah, so how do you make a completing square? Completing square. So we make a b over 2 squared, right? So in that case, we want to make a completing square respect to y. So let's make a x squared plus y squared minus y plus z squared equal to 0, right? Okay, so then b will be -1. B equal to -1. So we have -1 square, which is 104. Okay, then we will use positive 104 and then positive 104. So that will be, we are using -1/2 there. So x squared plus y minus 1/2 squared plus z squared equal to 104. Okay, so that will be r squared, right? So it's also sphere. Sphere and r equal to 1/2, right? And the center is 0, 1/2, 0. Yeah, make sense? Okay. Oh, thank you for watching today. It's hard a little bit. Yes. Okay, so this is 2.7. We finished that. This is the last section of chapter 2. So we will do chapter 3 next time. Thank you very much. Bye.